Kia ora koutou. I'm going to start videoing the Level 3 integration paper from this year, and I'm starting with question 1e. So we're given a graph, and it's got two curves in it. The first curve is y equals 3 sec squared x, and the second one is y equals 2 tan squared x. So this one here is y equals 3 sec squared x, and this one underneath here is y equals 2 tan of x. So it's a pretty straightforward problem. We're given the limits of integration. I'll be told, first of all, to find the area of the shaded region enclosed by the two curves, x equals 1 and the y-axis. So the x value here is 0, the x value here is 1. There's no crossover point, there's no weird intersection that we have to figure out. So it's a pretty simple integral to set up. The area will equal this. So the integral between 1 and 0 of the top function, 3 sec squared x minus 2 tan squared x dx. So I think it's worth at this stage just taking a breath and seeing what's easy in here to integrate and what's tricky, and then thinking about the link between the two functions, the sec squared and the tan squared. So sec squared x is really easy to integrate, right? Because we have the derivative of tan x is equal to sec squared x. This is much more painful because we don't have a reverse chain rule situation here. But happily, and if you're working on excellence level problems, you probably noticed this, we can link the tan squared to the sec squared using a version of this Pythagoras identity. So sine squared plus cos squared x is equal to 1. I'm going to divide everything through by cos squared x, and that gives me the link between tan squared of x plus 1 is equal to sec squared of x. Okay, so that's the key to solving this problem. We're going to substitute tan squared into here. So I'm going to do that outside of the integral, just to clean it up. So we have 3 sec squared x minus 2 tan squared x is equal to 3 sec squared x minus 2, and you can see here that tan squared of x is equal to sec squared of x minus 1. So that's what we'll substitute in here. So 2 times sec squared x minus 1, that gives me 3 sec squared x minus 2 sec squared x, so sec squared x, whoops, there we go, sec squared x plus 2. Now we're ready to get on and integrate, and it's a very simple integration. So the area will be from 1 to 0 of sec squared x plus 2 integrated with respect to x. When we integrate sec squared of x, we get a straight up tan of x, nothing to do, no mucking around with coefficients or chain rule or anything, plus 2x evaluated at 1 and 0, and that gives me tan of 1 plus 2 minus tan of 0, which is 0, plus 0. And when you chuck that in your calculator, you will get out 3.5574, and that's to 4 decimal places. So just to check that I hadn't mucked it up, I went to GeoGebra and I graphed it, and this is what I got. Okay, so I'm feeling reasonably confident about that answer. I'm sure someone will tell me if I've got that wrong, but that's the first of the excellence questions, I think, from this year's integration paper. Thanks for watching, and I will do some more level 3 questions later, and maybe some scholarship stuff too.